We live in a world built on foundations we rarely see. We switch on a light, solve a complex equation, or visit a doctor all without a second thought. Yet, these simple acts are the final chapters of a long and profound story. It is a story of discovery, of relentless curiosity, and of a civilization that became the world's intellectual heart. This was the Islamic Golden Age. During this era, Baghdad, Cordoba, scholars didn't just preserve ancient knowledge, they forged it anew. They built upon the works of the Greeks and Romans, then added something uniquely their own, a spirit of inquiry fueled by reason and faith. They became the architects of a future they could only imagine, and their blueprints are still in use today. The names may not be as familiar as Newton or Galileo, but their impact is just as monumental. Think of Ibn al-Haytham, Al-Khwarizmi, Ibn Sina. They were not just thinkers. They were pioneers venturing into uncharted territories of the mind. For centuries, the greatest minds Euclid Ptolemy believed we see because eyes emit rays that strike objects. It seemed intuitive, but it was wrong. A man from Basra, Abu Ali al-Hasan ibn al-Haytham, overturned a millennium of accepted wisdom. 10th, 11th centuries, Ibn al-Haytham, a true polymath. His greatest contribution, optics. Not content with speculation, he insisted on proof. Meticulous experiments, a darkened room, the original camera obscura. He demonstrated light travels from objects into our eyes, not the other way around, more than correcting an old theory, the birth of the scientific method. He formulated a hypothesis, designed experiments, recorded observations, used mathematics to analyze results. His 7-volume book of optics, Kitab al-Manazir. He explored the nature of light, reflection, refraction, mechanics of vision. Light travels in straight lines. He built the first camera obscura, observing an inverted image on a screen. Observation, experimentation, conclusion. The bedrock of modern science. Explaining vision laid foundations for eyeglasses, magnifying glasses, telescopes, cameras. Renaissance artists like Brunelleschi, Leonardo da Vinci used camera obscura principles to create linear perspective in art. Later Europeans, Roger Bacon, Johannes Kepler, Isaac Newton studied Latin translations and built on his work. His legacy, not just discoveries, but how he discovered them, courage, precision, and an unwavering commitment to the truth. Imagine a world without the number 0 or without a systematic way to solve for an unknown variable. It would be a world without modern engineering, finance, computing. We owe the tools to navigate this complexity to a 9th century Persian scholar working in Baghdad's House of Wisdom, Muhammad ibn Musa al-Khwarizmi. He did not invent numbers, but he revolutionized how we use them. His book, the compendious book on calculation by completion and balancing, or Al-Kitab al-Mukhtasar fi Hisab al-Jabr wa al-Muqabala, introduced a new way of thinking about mathematics. The word al-Jabr from its title gave us our modern term, algebra. Al-Khwarizmi's genius was to create a system for solving problems by manipulating symbols. He introduced a systematic method for solving linear equations and quadratic equations, not for abstract purposes, but to solve real-world problems. His book provided practical solutions for issues of inheritance, trade, land measurement. By describing a process and an algorithm for finding an unknown quantity, he created a universal language that could be applied to any problem. In fact, the very word algorithm is a Latinized corruption of his own name, Al-Khwarizmi. Before Al-Khwarizmi, mathematics was often clunky and descriptive. Problems were stated in full sentences and solutions were specific to each case. He abstracted the process, introducing the idea of finding an unknown thing, which would later evolve into the variable x in European mathematics. His methods of algebra, restoring or completion by moving a negative term to the other side, and al-Muqabala, balancing by subtracting equal quantities from both sides, are still the fundamental operations taught in every algebra class today. Furthermore, Al-Khwarizmi was instrumental in popularizing the Hindu numeral system, including the revolutionary concept of 0. Every time we use a computer, we are, in a sense, using an echo of Al-Khwarizmi's logic. In the history of medicine, few books have held as much authority for as long as the Canon of Medicine, or Al-Canun fi al-Tibb. Its author was Abu Ali al-Hussein ibn Sina, known in the West as Avicenna. a Persian prodigy who had mastered philosophy, law, and medicine by his late teens. Ibn Sina as you created a medical encyclopedia of breathtaking scope and detail in the 11th century. This 5-volume work was not just a collection of existing knowledge, it was a systematic organization of all medical understanding of its time, combining Greek traditions, Roman traditions with the discoveries of Islamic physicians, and enriched by his own extensive clinical observations. The Canon was revolutionary for its structure and its approach to medicine as a science. It systematically covered topics from general anatomy, physiology, specific diseases, treatments, a vast pharmacopoeia of over 760 drugs. Ibn Sina emphasized the importance of diagnosis, observation, clinical trials. He was among the first to describe meningitis, to differentiate between different types of paralysis, and to suggest that some diseases could be transmitted through water and soil. A precursor to germ theory. He also detailed surgical procedures and stressed the importance of factors like diet, climate, emotional well-being in maintaining health, a remarkably holistic view for his time. The influence of the Canon on global medicine is almost impossible to overstate. Soon after it was written, it was translated into Latin and became the standard medical textbook in European universities for over 600 years, well into the 17th century. Aspiring doctors from Paris to Padua studied Ibn Sina's words as gospel. Beyond his specific medical discoveries, Ibn Sina embodied the ideal of the scholar-physician. His writings integrated the physical with the psychological, recognizing the deep connection between mind and body, a concept that modern medicine is only now fully embracing. When we look back at the achievements of the Islamic Golden Age, it's easy to see them simply as a series of brilliant inventions, a new theory of light, a new branch of mathematics, a comprehensive medical text. But honestly, this perspective misses the deeper significance of their work. These scholars were not just creating tools, they were articulating universal principles. Ibn al-Haytham's scientific method was not just for studying optics, it was a blueprint for how to question the world and seek truth through evidence. It was a universal methodology for separating fact from speculation, applicable to any field of inquiry in any culture at any time. Similarly, Al-Khwarizmi's algebra was more than a technique for solving inheritance puzzles. It was the creation of a language of pure logic and abstraction. It provided a framework for breaking down complex problems into manageable steps and for thinking systematically about relationships between quantities. This is a blueprint for problem solving itself. It's a way of thinking that is as useful for designing a bridge or writing a computer program as it is for balancing an equation. The pioneers of this era were perhaps unknowingly drafting the operating system for modern rational thought, a system intended for all of humanity to use. The same can be said of Ibn Sina's canon of medicine. Its value was not just in its specific remedies, but in its underlying philosophy that medicine should be systematic, evidence-based, and holistic. The canon presented a blueprint for public health, for medical education, and for the ethical practice of healing. Proposed a universal standard of care where knowledge is organized, tested, and shared for the benefit of all. This principle, that healthcare should be built on a foundation of rigorous, universally accessible knowledge, remains the guiding ideal of medicine today. What if we were to view these contributions not as historical artifacts, but as a deliberate offering to the world? What if the intention behind this explosion of knowledge was to provide a set of universal blueprints for progress? This perspective really transforms our understanding of history. It suggests that these scholars saw their work as part of a larger human project. They were building intellectual infrastructure, frameworks for thinking, problem solving, and healing that could be adopted and adapted by any society seeking to advance. It is no coincidence that this scientific flourishing occurred within an Islamic civilization. The pursuit of knowledge was not seen as a secular distraction from faith. It was actually considered a religious duty, a form of worship. The Qur'an and the sayings of the Prophet Muhammad are filled with injunctions that encourage believers to learn, to observe, to reflect on the natural world. Verses repeatedly call on people to look at the stars, the alternation of day and night, the creation of life itself as signs or ayat for those who have understanding. The universe was seen as a book filled with divine signs, and the act of studying it was a way of getting closer to its author. This perspective gave scientific inquiry a profound sense of purpose. The Prophet Muhammad is reported to have said, "Seek knowledge even unto China," which is a pretty powerful statement encouraging believers to travel far and wide in their quest for understanding. This created a culture that valued scholars, built great libraries, sponsored massive translation projects to gather the wisdom of the world. Knowledge was not feared as a threat to faith. It was embraced as a path to a deeper appreciation of the divine. The study of algebra was seen as an exploration of the universe's inherent logic and balance, while the study of anatomy was a way to marvel at the perfection of God's creation. This divine mandate fostered a unique intellectual environment where faith and reason were not seen as adversaries, but as complementary paths to truth. Scholars like al-Haytham, Ibn Sina, for them, a rational understanding of the physical world only enhanced their awe of its creator. This synthesis allowed them to pursue empirical investigation with a rigor that was unprecedented. Science was a sacred trust, a means of fulfilling the human potential for reason and reflection that God had granted. This powerful connection between faith and inquiry is a crucial part of the story. It explains the why behind this golden age. The drive to create, discover, and systematize was fueled by a worldview that saw the universe as knowable and the act of knowing as a virtuous one. Let us engage in a thought experiment. Imagine a world where the universal blueprints offered by Islamic genius were not just partially absorbed by Europe over centuries, but consciously adopted as a global framework for progress. What if the scientific method championed by Ibn al-Haytham had become the immediate worldwide standard for inquiry long before the 17th century? Societies everywhere might have embraced empirical evidence and critical thinking as the basis for governance and development, leading to an earlier, more widespread enlightenment. In this alternate history, Al-Khwarizmi's algebra would be more than a mathematical tool. Its principles of balance and systematic logic would be applied to social and economic structures. Imagine societies designed with the elegance of an equation where al-jabr, or restoration, is applied to social justice, ensuring that the disadvantaged are supported. Al-Muqabala or balancing is used to create equitable economic systems. The search for X, the unknown, so that would become a metaphor for social policy, a constant rational effort to solve for the well-being of all citizens. Now, picture a world where Ibn Sina's holistic and systematic approach to medicine was the universal foundation for healthcare from the 11th century onward. Public health systems based on prevention, hygiene, evidence-based practice could have become the norm centuries earlier. The emphasis on the connection between mental and physical well-being might have led to more compassionate and effective forms of care. The systematic organization of medical knowledge could have fostered global collaboration, allowing discoveries to be shared and implemented rapidly, potentially preventing or mitigating the devastating plagues that swept across the world in later centuries. This is not a utopian fantasy, but a projection based on the principles these scholars laid down. It imagines a world that took the core message of their work to heart, that progress should be rational, systematic, and aimed at the betterment of all humanity. The spirit of the House of Wisdom, collaborative, multi-faith, and relentlessly curious, could have become the model for global institutions, fostering a shared sense of purpose in the human quest for understanding and a better life for everyone everywhere. At least the Golden Age may have faded, but its echoes never fell silent. They continue to resonate in our modern world, often in ways we fail to recognize. Every time a scientist forms a hypothesis and tests it with an experiment, they are walking in the footsteps of Ibn al-Haytham. His insistence on empirical proof and his methodical approach are embedded in how science is done today. We call it the scientific method, forgetting the man who pioneered it. The language of science and technology is filled with echoes. Algebra, algorithm, alkali, linguistic fossils pointing back to an era of immense creativity. An astronomer uses a telescope whose optical principles were first explored in Baghdad and Cairo. A doctor consults a medical textbook participating in a tradition perfected by Ibn Sina. These are not trivial connections. They remind us our present is built on layers of history, many laid by scholars of the Islamic world. This legacy challenges the simplistic history that jumps from ancient Greece to the Renaissance, missing a crucial 1,000 years. Acknowledging the Islamic Golden Age gives a richer picture of human progress. Science and learning are shared human heritage. The light of knowledge passed between peoples over time, and for a brilliant period, the Islamic world was a dedicated standard bearer, preserving ancient wisdom and adding immeasurably to it. Understanding this history fosters mutual respect today. As we stand here today on September 1st, 2025, we face global challenges that require global solutions. Climate change, pandemics, inequality demand that we harness the very best of human ingenuity. The story of the Islamic Golden Age offers us more than just a history lesson. It provides an inspiring model for how to move forward. It teaches us that the pursuit of knowledge is a unifying force capable of transcending cultural and religious divides. It shows us that faith and reason, far from being enemies, can be powerful allies in the quest to understand our world and improve the human condition. The central lesson from these pioneers is the importance of a universalist vision. We must recapture this spirit today. Science must be a global collaboration, a shared enterprise where discoveries are made available to all for the benefit of all. By looking back at their achievements, we can find inspiration for the path ahead, working together to build a future that is as brilliant and humane as their greatest aspirations.